Sometimes in Java, we want to define a class whose behavior is needed as part of another class. We do this by nesting classes. This defines one class inside of another class. Two ways to do this are static member classes and inner classes. So B here is a static member class of A. We could declare it as public, protected, private, whatever access level we want, but B in this example is static at least. That means it belongs to the class A, not to particular instances of A. And what this allows us to do is to give B access to any of the methods and fields of A, even the private ones. You may have seen this kind of inner nesting thing if you've written a linked list or a tree in Java or a comparable language before, where you might define the node class inside of the list class or that sort of thing. You may or may not have used static member classes versus inner classes. So a static one will exist for the class. You would refer to it as things like A.B. And an inner class would be a non-static member class or a local class or an anonymous class, and we'll look at examples of all of those. It exists particular to an instance or an object of the enclosing class, so we would need an A object if we were dealing with some inner class to refer to the inner class that way. Here we have a non-static member class called B, so it's not static here, and we've made it private to A. So that means that we're not going to be able to refer to B objects outside of the A class. So here B has its own variable y, A has variable x, but B can refer to both x and y because it's inside of the class A. So it's able to refer to any of the data from B or from A. It's also allowed to call the member methods of A as well. Because it is not static, then we need an instance of class A to create an instance of class B. So we create, for example, a new A with the value 2, and then to create a B, we will need to call A.getB, or we can say A.new. It's a very strange syntax, but it would allow us to create an object of type B. We cannot just create B's outside of the class. We need an instance of A to get one. So in B, the instance that it belongs to may be accessed by doing A.this. For example, you can say return A.this.x. If there's an x in both A and B, for example, then we can access it that way, and we can just use this.y to get B's data. When B is visible outside of A, then its full name is A.b. It's most useful when B is visible or an interface of some sort is used to define the B's behavior. For instance, when we define some node interface that we'll then be using for B. So we have an instance of B that can refer to A.this to get access to the instance of A for this non-static member class there. As I mentioned, we can use this strange something.new syntax to create new objects of type B. So here we have we have an inner class from outer class here, and when we want to create objects of the inner type, then we need an instance of outer, called O here, and we then say O.new inner. Its type will be outer.inner. Here we've got some generics, so it makes it look even funkier. And so you'll sometimes, but very rarely, see this syntax of O.new inner that allows us to create an inner object, but we need an O instance to refer to. So for instance, if I wanted a bare node from my linked list, and I had a linked list called L, then I might be able to say L.new node. You don't have to do this outside of the two classes or inside of the two classes. You will only have to do this kind of thing in like a main method or another class that's using them if you wanted to be able to get access to, for instance, a new node object to try out some stuff related to your linked list. It's usually bad behavior. It usually means that you've probably exposed some functionality that should have been encapsulated and hidden away. For example, your users don't typically want to access linked list nodes. They typically want to ask the linked list for things and to get data out of that linked list. So it's discouraged as behavior at the very least. One thing that you might sometimes do is define a local class that is adding some functionality, but that you really only need for a certain amount of time. For instance, here we've created a click listener. This would be useful for a user interface that needs a button to be ready to listen for people clicking it. We don't really need to write a separate Java file and define a click listener or button click listener class or something like that. We can just define it locally here. And you can see it's actually local inside of the function. So when someone says, set some handlers for my button or for my window, then it creates this new class there in the spot. It's very similar to non-static member classes, except B is not visible outside of that block where it's defined. So if I don't really care about B out here in the rest of my program, I just want to be able to set those click listeners and have them do the right behavior when something is clicked, then I can define it right there in that spot, and I can set the click listener to be a new B right there in that space. So we're not able to reference B outside of that method that sets the handlers, and we don't need any modifier public or private because it's local. We're not able to do that A.B kind of language to create new B objects, again, because they don't exist outside of this space and they don't need to. I've created the behavior I needed for clicking. I set the listener, and so that B object is going to get called. Its methods will get called whenever some click happens. So it's all local to that space. If you've done Android or other user interface type programming in Java, you've probably seen something like this, even if you didn't understand it. An even shorter hand way of doing this kind of thing is to use anonymous classes where we don't even give them a name. Our previous one was called B. We didn't need a name for it because it stopped existing at the end of the method that it was created in. So here, I've skipped a step and I've just said button.setClickListener to new click listener, and in that space I give brackets and I define the full body of the class there. This is useful for simple classes like a click listener that only needs one or two methods, and it wouldn't really make sense to define it as some other class. It has no name. It typically has no constructor. We use initialization blocks for it there. And the class can only be instantiated in this one place. It starts and stops existing inside of the parentheses to that set click listener call there. It could be written with its own attributes as well if we needed it to, like a count of how many clicks have been done or things like that. You're not going to be able to access those attributes outside of that space though, because again, you won't be able to refer to the class and get the stuff from it. So it can be very useful for simple little short things. I've written these sometimes and then decided later to expand them out to be an inner class or an inner class or to be their own separate class if I've found I needed to reuse it somewhere. But most of the time when you're writing listeners or other short little things that just handle some specific behavior, you can use an anonymous class for that. So when we use the keyword new, in fact, in Java, we always thought that we could just use it to call constructors, but actually it can be followed with a class name or an interface name using these local classes or these anonymous classes. So we could return a new A and then define what the A class looks like right there in that space, which is the same as creating a class A1 that extends A and create the actual functionality for that A1 class, and then returning a new A1 object. These are equivalent here. It's just I gave it a name for this new class, this A1, where here I'm extending the A class automatically by just saying new A and then giving it its body to that class. And the same thing is true here. I can do an interface name, which is the sort of thing we did for that click listener before. We didn't have to give it a type name like B. We just told it, you're going to be a click listener, and here is the behavior that you're going to get inside of there. And so it will automatically extend or implement, and it will automatically use that thing without needing a name specific to it. So this lower one uses an interface and would define the body of all of the methods that are required for that interface. And that's the same as creating a class I1 and making all of the bodies for the methods and returning a new I1. So these nested classes, static member classes or inner classes, they can give us functionality that belongs within some limited space. They may belong within another class. They may belong within a method only. And they may even belong only within a particular call to a function or one particular line of our program where we're doing things like setting a listener or establishing a network connection or different things like that that are very specific to that location and that behavior that we want in that spot.